Out of all the lectures that we've viewed so far, this one is probably the most important. Now you might want to watch this lecture over and over until you thoroughly understand what I'm talking about, okay? First, let's go back and review our triangles. Remember, we basically have two special triangles. We can call it three if we just interchange these two angles. But I will refresh your memory. Remember the special relationship of the pi over 4 right triangle is 1, 1, square root 2. The pi over 6, pi over 3 right triangle is a 1, 2, square root of 3 triangle, where the square root of 3 is always opposite the pi thirds. And if I went ahead and switched this triangle around and I had a pi over 3, pi over 6 right triangle, it still has the same relationship where the square root of 3 is always opposite the pi over 3. Okay? All right. So let's go back. Here's our unit circle. We just talked about that in the earlier lecture if you watched that. Here's our new goal. Given an angle theta in radians, we want to find the corresponding x and y coordinates that are on the unit circle. In other words, I'm going to start here with an angle. Maybe there's an angle of pi fourths. I want to know what's the corresponding point on the unit circle. Maybe I'm talking about the angle pi. I want to know what the corresponding point is for the angle pi, etc. So given any radian measure, we're going to have a corresponding point on that circle, and we want to be able to find all of those points. All right, let's start with some easy ones, okay? So, given an angle, okay, given an angle of 0, I want to find the corresponding point on the unit circle. Well, an angle of 0 is just the ray going out this way. We haven't started any rotation, so the angle of 0 is just this ray going out here. Remember, the unit circle has a radius of 1, so the corresponding point on the unit circle that corresponds to the angle of 0 is the point 1, 0. Okay? That's all we're doing. Now, given an angle of pi halves, there's pi halves, the right angle. Notice I'm right here. What's that point? Well, that's the point 0, 1. So given an angle of pi halves, the corresponding point on the unit circle is 0, 1. And notice these are the easy points. Okay, they're all multiples of pi halves. I'm just going to increment in pi halves. The corresponding angle to pi, or 180 degrees, is right here. And that's the point -1, 0. And we'll do 3 pi halves next. That's 270 degree rotation. So that puts us here. And that's the point 0, -1. And then 2 pi, of course, we're all the way back to where we started from, right here, 1, 0. Okay, so not too difficult so far. All right, let's continue. Now is when it starts to get a little tricky. It says, if theta equals pi fourths, find the corresponding point on the unit circle. So let's sketch this. So pi fourths, that's this 45 degree angle. There's pi fourths right there. Now we want to figure out what is this point. Well, how are we going to do this? Well, notice if I drop a perpendicular line straight down, I'll just go ahead and make a dotted line. I have created a right triangle. Now, I know a special relationship on a pi over 4 right triangle. It's this one right here. So I'm going to write that to the side here. Now, what side do I know? Well, I know that this is a unit circle, which means the radius is always 1 unit. Okay? So if that is 1, how are we going to find the x value, or this length? And how are we going to find the y value for that length? Well, we talked about similar triangles. Notice that square root of 2 times sum k must equal 1. So k is equal to 1 over the square root of 2. You might want to review the lecture on similar triangles. Okay. Therefore, if this is square root of 2, this is going to be square root of 2 times 1 over root 2, which is 1. 1 times 1 over root 2 is 1 over root 2. 1 times 1 over root 2 is 1 over root 2. So now I know that point. Notice the x-coordinate is this distance here, this length, which is 1 over root 2. The y-coordinate is also 1 over root 2. Okay? So, if theta is pi over 4, the corresponding point is 1 over the square root of 2. Okay. Let's do a couple more. All right, let's try this one. If theta equals 2 pi over 3, let's find the corresponding point. So here's a new clean unit circle. And we're given that theta equals 2 pi thirds. Or that's about 120 degrees. So it's exactly 120 degrees. So let's make an angle of 120 degrees, or 2 pi thirds. So I got to go 90 and 30 more. So I'm about right here. So there's an angle of 2 pi thirds. Let's figure out what that corresponding point is. Again, let's go ahead and drop a perpendicular to create this little right triangle. Now I have to figure out what are the angles of this right triangle. Okay? Well, if this is 2 pi thirds from here to here, right? I know the whole angle, the whole straight angle from here to here is pi. So this has to be pi minus 2/3 pi, or pi thirds. Notice 2 pi thirds plus another pi thirds gives us that whole straight angle of pi. So therefore this is pi 6. Okay, and I know that this is a unit circle, so the radius is 1. And let's now find the x and y coordinates. So if I refer back to my special right triangle, okay, I'm going to refer to this one here. I know the relationship is 1 to square root 3. So I know this is the square root of 3, this is 1, this is 2. And now let's go ahead and find the corresponding lengths over here. Well, let's figure out our k. Notice 2 times k is equal to 1. So k is a half. Now, if I want to find this length here, okay, 1 times a half is a half. But here's where it gets a little tricky. So listen closely. Notice I'm in the Cartesian coordinate system. So yes, this length is a half. But since I'm over in the negative direction, okay, that means that this x-coordinate is negative 1/2. Okay? That's very important that we get the signs correct. Okay? Now, let's see what the y-coordinate is. Well, I know my k was a half. Square root of 3 times a half is square root of 3 over 2. And that is a positive value, since we're in the up direction. So given an angle of 2 pi thirds, we have found the corresponding point to be negative half square root of 3 over 2. Again, this is a very important lecture, and you might want to view it a couple times. Let's do one last example. Let's find the corresponding point on the unit circle if we're given an angle of 7 pi over 4. So let's construct that angle. 7 pi over 4. If there's my initial side, I have to go all the way around. Let's see, there's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. So there's my angle of 7 pi-fourths. And now let's figure out what that point is right there on the circle. Again, go from the point, and we will create a right triangle. Remember, the unit here is always 1 because we're on the unit circle. Now, what's this angle right here? What's the angle of this triangle? Well, if this is 7 pi-fourths, I know it's 8 pi-fourths all the way around because that's 2 pi. So therefore, this has to be a pi-fourths angle. So that has to be a pi-fourths angle. And given an angle of pi-fourths, I know the general relationship is 1 squared 2. Okay. So again, this is very similar to that other example. The relationship is k equals 1 over root 2. So if I want to get this side, 1 times 1 over root 2 is 1 over root 2. Now note that is positive since we're in the positive x direction. The y value is going to be 1 times 1 over root 2, but we're in the negative y direction. So that gives us the point x is 1 over root 2, y negative 1 over root 2. Okay? Again, you may want to go back and view this lecture a couple times. It is a little tricky, but once you get the hang of it, it's not too hard. Notice we can find any point on this circle that corresponds to an angle of 0, pi-halves, pi, 3 pi-halves, etc. Any increment of pi-fourths, any increment of pi-thirds, any increment of pi-sixths. It's all relatively easy to find those points. And it's very important that you can do so as well.